Hello, my name is Marcel, the product manager of our YAMS environment, and I'm proud to present you our latest features we released with version 24.1. Let's go! We have implemented the function to add and edit signals inside the assistance. Therefore, you can find the inline field on the top of the signal lists. This is used to also validate the signals before adding them to the list. It is not possible to add signals with the same name, and the combination of address and data type will be checked as well. The same function we have included for the DS attributes. You can now manually add and edit DS attributes for every signal. So if there are signals used in virtual commissioning without DS attributes, but you want to have the function for DS mode in our Scout, you can add this directly in our YAMS assistance. For some specific use cases, it can be helpful to know which product is currently at a specific place, similar to the skid number and copying conveyor technique. Therefore, we have implemented the index number and part instance for products. You can simply drop integer output signals to the fields at every buffer you need. You can use the same signal for different buffer at the same station. The index number is equal to the list number of the products. If no product is placed at the buffer, both values will be -1. The instance number will always increase for every created product, so you have only unique products, and in RF Viper you can use this information for your logic. Sometimes, the normals of the geometry are not correctly set in the CAD program. This results in wrong lightening in RF YAMS, because the normals are pointing to the inside, and it lightens the inside on the outside surface. You can afterwards see almost black materials. To fix this issue, we have created a function to check these triangle normals and correct them. This correction will only be done at the selected bodies, so select the object above the body or the body directly to execute the repair function. We have made some UI changes and implemented a few quality of life functions. At first, you can now choose between a frameless RF YAMS and the original one. This gives a little bit more space. With the introduction of frames, it was quite hard to separate the frame coordinate system from the body coordinate system, even if the body one is slightly bigger. You can now simply activate and deactivate the rendering of the frames among your preference. Also, we have implemented a search function in our YAMS project when you click Addit at the top node of the project tree. And when creating a joint between two bodies or tracks, the order of the first and second body will be the same as the selection order. With version 23.2, we have introduced the possibility to create or convert traces in USD to load in NVIDIA Omniverse. With version 24.1, we now have implemented the first iteration of our live Omniverse connector. To use it, you need to create a Nucleus server on the Omniverse launcher. This server can run at the same or also on another computer as RF YAMS. You can copy the URL of this server to the field in RF YAMS. Change the IP address if necessary and put the wished project name .live at the end of the URL. Click on the already known rec button to create a live layer. After this, you can load this layer in NVIDIA Omniverse, and the changes of RF YAMS will be directly visible in here. Our biggest new feature for version 24.1 is the possibility to update process simulate 3D data in RF YAMS. Therefore, we have created a separate function you can open below Tools. In this window, you will have a various amount of possibilities to compare the projects and decide what you want to update and what you do not want to update. You can move through the project by hand and have a direct look at the highlighted elements. Or after compare, you can show the selected items isolated in 3D view. You can choose by yourself which fields of YAMS elements you want to consider for comparison, such as name, coordinate system, project structure and more. A detailed selection is placed in preferences. For comparison, the system will recognize the different elements in both projects via the unique ID from Process Simulate. Elements without ID will receive one from YAMS with specific rules while importing. Only elements with the same ID and elements which were imported via PSZ can be compared. In 3D view, you will see both cells at the same time. You can choose to manually merge elements or to merge the whole project at once. The assistant's created content will be kept as far as possible, but if a station is removed from the project or replaced, you will need to delete these elements in assistance afterwards too, and connect the new elements again.